All right, so we did 26 yesterday, which was the first one that we had to figure out you ourselves. So we're just going to keep working down through them. 28 is the integral of secant of theta plus pi over 2, tangent of theta plus pi over 2, d theta. So, what is u?
I'm going to go with theta plus pi over 2.
Theta plus pi over 2. So then what would du be? So what's the derivative of theta plus pi over 2?
Oh, dx, or d theta.
D theta. So du would just be d theta.
Oh.
Because the derivative of theta is 1, but you
Pi
don't
is
need to write the
not a-
1.
Pi is not a variable.
Pi is a number.
Pi is a number.
Forever and always, pi is a number. So I have the integral of secant of u, tangent of u, du. I noticed in this one I didn't have anything we had to take out, just like in number 26. So what is the antiderivative of secant of u, tangent of u? Secant of u plus c. And then we do the replacing. So we get the secant of theta plus pi over 2 plus c. Now again with this one, you might could have seen this one without needing to use u substitution. But as we go, they're obviously going to get harder and you're going to really need that u substitution thing. Bless you. Let's see, 30. The integral of 3 parentheses sine of x raised to the negative 2 dx. Ideas for you. So u equals sine of x. So du equals dx. Now, do I have a cosine in this? I don't. So I'm going to divide by 1 over the cosine of x. I haven't done this one yet, so we're going to see if this works. All right, so we'll put the I'm going to move the 3 out front. I don't think we can move that 1 over cosine out front because it has an x in it. And I also can't have stuff with x's left in it. He had to clear the microwave. Thinking about this one. We might have to come back to this one when I can think about it a little more.
Did we choose the wrong thing as you? I don't know what else we choose
1 over. Okay, sine to the, this might be what you were saying. So this would be the same as, disregard what's in blue for just a second, as 1 over sine squared of x. Ah, there we go.
Okay. Yes, that's what we had to do.
I think so.
Maybe.
So disregard what's in blue for the moment. We might need to manipulate and change what we're doing. But what is 1 over sine squared of x equal to? Cosecant squared. So 3 integral of cosecant squared of x dx. Now, do we know what the antiderivative of cosecant squared is?
C is cosecant x cotangent.
No, that's
No, that would be a derivative.
no.
The opposite direction. The derivative of what trig function gives me cosecant squared? And it might possibly give you negative cosecant squared, and you might need to make whatever it is negative.
Why is
Negative cotangent.
Negative cotangent, because the derivative of cotangent would be minus cosecant squared, right?
Yes.
Okay, so this would be 3, well, negative 3 cotangent of x, not dx, plus c.
So we don't need.
So in this one, we didn't actually need u substitution.
Okay.
Now, there probably is a way to do it with u substitution, but we didn't need it, and it was not working for me with it. So, but that's the thing. So, like, honestly, kind of good that we tried that, and we're like, this isn't, because we can't leave an, like, I can't pull that x term out front. I couldn't have put the 1 over cosine of x out front, because that would have something that needed to be integrated. But putting it inside just made it more complicated. And so it was like, okay, well, let me see if there's a way I can rewrite it. And so sometimes that's, you know, what we have to do. This one looks interesting.
Oh gosh.
I'm trying to do like as many with you as I can so that you get like used to it, because they can all just be very different.
Yeah.
All right, this one is the square root of the cotangent of x times cosecant squared of x dx. What do we think with this one? Could be you.
Cotangent. Root cotangent x. I meant to say cosecant squared x. X.
What did I say we normally want to go with when
The
we're
bigger
picking
one.
you?
Bigger. So cosecant squared x.
Huh?
U is cosecant squared x.
So the other thing to look at is something that I have give me the derivative of the other thing? Or like, if I take it and I take the derivative, do I get the other thing? So I said yesterday that u is typically something in a parentheses, in a square root, or in a trig function. So what was wrong with what Nathan initially told me u was?
He said with the square root?
Correct.
Oh, so it's
Not the square root.
Just cotangent.
Just cotangent of x.
Oh. See, that's why I was sitting there confused, because I thought just said cotangent.
I'm just like, what is
You did
left?
say that first, but then you switched his answer to the square root.
What's
He kept changing his mind and wouldn't give me a final answer. So what's du?
Negative cosecant squared dx.
That's why I wrote the x and I was like, wait, she said dx, but I still need to have the x there. All right, now, do I have a minus cosecant squared of x dx in the integral?
Not a minus.
I don't have the minus, so I'm going to divide by the negative, so negative du is equal to cosecant squared x dx. So now, when I come over here, I'm going to have negative integral. I'm going to write this cotangent that's in the square root as u to the 1/2. Makes it easier to deal with. Then the cosecant squared of x dx is taken care of with du. So now, what is the antiderivative of u to the 1/2? And don't forget your negative that's out front.
2/3 u to the 3.
2/3 u to the 3/2
du plus c?
plus c. So then plugging it back in, negative 2/3 times the cotangent of x to the 3/2 and plus c. How are we feeling about these so far?
I'd say
Yeah, we feeling
I'm
okay.
feeling okay. I think so.
It's just like a, you know.
Yeah.
Just like they're all different and I haven't figured
Yeah.
out it all yet.
Yeah. Maybe a little bit.
34. The integral of tangent to the 7th of x over 2
Because that is
secant squared of x over 2 dx.
So u is gonna be x over 2.
And the derivative is
0. Wait, that's not where
No.
it's going.
Wait, so okay. So
1/2.
x over 2 is
1/2.
1/2 x, yeah.
so 1/2 dx. Do I have a 1/2 over there?
Yes, you do.
You have a 1/2
Yeah,
x.
about 1/2. It's not already defined. So it's
Yeah. So like no, I don't.
Yeah, no.
So this is going to be 2 du equals dx. So I have 2 integral tangent to the 7th of u secant squared of u du. Now what?
Okay.
plug that in.
Well, I haven't taken the antiderivative yet, so I can't plug it back in.
Let me see here.
Where are you going?
Where am I going? So, the 7 and the 2 is what's confusing. Because if we could take the antiderivative of tangent u secant u, because that is just the derivative of secant,
Right.
but the numbers is what's.
Well, if I
Technically,
hypothetically rewrote it this way for you,
Right. Like, secant u, the derivative of that is secant u tangent u secant u is the same thing.
anyone have any ideas? Or do you think we've done this right so far?
Huh?
Do you think we chose the right u?
Maybe.
Is that the only
Well, do you think we picked the right value for you to be?
Yes.
Nathan strongly thinks we have.
I don't know.
Then take the antiderivative of this for me.
Yeah, I don't know how to do that.
Oh, this one.
I guess did we get tangent?
Ah, yes. Yes, we did.
Wow. Oh, because it's the highest value.
So I wouldn't get rid of it, but I would maybe put a slash through it so when you go back and you see for reference, okay? And I say this from the standpoint that I've done this very same thing before. If you look at my paper, I have the exact same thing on there.
You were just gonna let us go down this.
Yeah, because I wanted you to see that sometimes you pick the wrong thing. It looks like it would work. It followed the rules. It was inside of a trig function. It was in a parentheses. Seems like a great place to start. But then you got to a point when you still didn't know what to do. And when you get to that point, a lot of times you should probably think, maybe I didn't pick the right thing.
I was just thinking that. I was
Okay.
like, wait, did I miss the part where I was supposed
Right.
to know how to answer? Do
I was
antiderivative
like, oh, did I
tangent?
miss that chapter, that section?
Okay? Because what am I visually seeing? Okay? I see that I have tangent and I see a secant squared and I know the derivative of tangent is secant squared. Okay? So, my new u, new year, new u, is supposed to be tangent, I don't know why that u is so large, of x over 2. Then what does that make my du?
One half?
Chain rule.
Oh,
Secant squared of x over 2 times 1/2 dx.
Okay, now, do I have 1/2 secant squared of x over 2? Up
no
here.
1/2.
No 1/2, so I still need to multiply it over. So 2 du equals secant squared of x over 2 dx. So now, I have 2 integral of u to the 7th du. Now, does this look like something we can take the antiderivative of?
Yes.
yeah.
So see, it should make your life easier if you're at the point where it looks like it made it harder or only oh so slightly easier, then you probably should try a different value for u. Okay? So you're probably like, why did she let us just go down this rabbit trail? Because I wanted you to see that that happens. Okay? So what is the antiderivative of this?
1/8 u to the 8th.
1/8 u to the 8th, and I have times 2 over here.
That's C.
Yep, plus c. So this is going to be 1/4. I'm going to go ahead and replace tangent to the 8th of x over 2 plus c.
Yeah, you start short.
36. Integral dx over sine squared of 3x. These bugs are going to drive me insane. Get over here. I'm like a million of them.
You get bugs.
Don't understand where they're coming from. Okay, anyways.
What?
Ideas for you.
Can we
Wait, we can change.
rewrite that real
Yeah, we can rewrite.
I was gonna say let's rewrite it first. Yep, that's a good thing to do, and that might not always be the right path, but
But
it is the right path on this one. I won't lead you astray on that part. So this would be the integral of what?
1 over sine 2, 3.
Sine 2, 3x.
I don't know, I said it wrong.
Oh.
Sine squared.
Maybe you're telling me the wrong way to rewrite this.
Yeah.
Okay. Are you just trying to get me to rewrite it as 1 over sine squared of 3x dx?
That is what I thought we were doing.
Okay, is there another way I can rewrite it? Like, yes, the dx is going at the end, but it doesn't matter if the dx is on top or at the end. I don't have to rewrite it because of that. What is 1 over sine squared of 3x? Cosecant squared of 3x. That would be a better place to start from. Now, what do we think u is?
I say 3x.
3x?
We know what.
You
We
did.
can solve cosine.
Yep. So du would be dx. Do I have a 3 dx on that side? No. So I'm going to have 1/3 du equals dx. So now 1/3 integral cosecant squared u du. Antiderivative of cosecant squared of u is negative cotangent, so negative 1/3 cotangent of u plus c. And then replace negative 1/3 cotangent of 3x plus c. And if you ever doubt that when you get to the end that you've done it correctly, all you have to do is take the derivative and you should get back to what was in your integral originally.
Well,
Oh, that makes sense. I guess that makes sense because it's the negative derivative.
Yeah.
that's
Well, in the plus c part, when you take the derivative, just goes away because that's a constant.
Yeah.
So you don't have to worry about that part. 38. The integral 6 cosine of t divided by parentheses 2 plus sine t squared dt. Anyone have any thoughts about this one?
2 plus sine t.
Okay, so let's let u equal 2 plus sine of t. It's a good guess because we're inside of a parentheses and that parentheses is being raised to a power. And, to top it all off, it's in the denominator. So,
Yeah.
not that the denominator necessarily makes a difference, but sometimes it does. So what's the du?
Cosine t dt.
Cosine t dt. And do I have cosine t dt?
Oh,
Yes.
yes.
Yes, I do. It's on top. Now, what else do I have on top?
A 6.
What can I do with that?
Pull it out.
Pull it out front. So, I'm going to have 6 integral 1 over u squared du. And how can I rewrite this to make this easier to deal with?
to the negative 2.
Yep, 6 integral of u to the negative 2 du.
We can side. Negative u to the negative 1 plus c. The 6 in front.
Yeah, I meant to leave room and I forgot, so. So then replace, and I would move this piece back to the bottom as well, okay? So I'm just going to do it in one step. So negative 6 over 2 plus sine of t plus c. No, that one wasn't too bad. Let's do one more for today. And then we should probably be able to wrap this up tomorrow. We'll jump through. We've done quite a few today, so.
Okay, this section just like about repetition.
Yeah, it is, honestly. Well, and then we're going to jump down to things like where we have to use trig identities for the substitution. Be kind of what we get into tomorrow, so. Let's do one more of this kind. Which one do I want to do? That one's just like one we already did, so I'm not going to do that one again. I was going to do 40, but I'm not going to. Just because we haven't had one like this yet, I am going to do an odd one, and we're going to do 39. The integral of dx over x ln of x. Ideas for you? Huh? Yep. ln x. Then what's du? 1 over x dx. Do I have that?
Yeah.
Yes. So I have the integral of, let's see, 1 over u du. What is the antiderivative of this? And I'm going to remind you that it's the absolute value of u, because this could hypothetically give us an issue here, depending on obviously what it is. So ln of the absolute value of u plus c. Then we replace, so we would have ln of the absolute value of ln of x plus c. Now, can the ln of x ever come out to be negative? No. So I could just put parentheses around it, but for the sake of you remembering, we'll leave the absolute value bars. It can't be wrong with them. You know, it just is there. So, I think tomorrow we'll move into using the given trig identity substitution. So trig identities will come back. I was going to say to haunt you, but maybe not.
Yeah.
Then we've got a few definite integrals that we need to use substitution for. So we'll go back to a few definite integrals where they give us something specific, and then we'll be done with this section. So we've probably got about 6 problems left to do in this section, and then, yeah, that'll be that. I presume y'all still don't want problems.